Hello. Today we're going to explore the fascinating relationship between lines that are parallel and lines that are perpendicular. By the end of this video, you will be able to determine if two lines are parallel or perpendicular by comparing their slopes, and you'll be able to write the equation of a line that is parallel or perpendicular to a given line. Before we dive into that, let's quickly review the most important concept for this topic: slope. Slope, often represented by the letter m, is a measure of a line's steepness. It tells us how much the line rises or falls for every unit it moves horizontally. We calculate slope using the formula, rise over run, which is the change in y divided by the change in x. If we have 2 points on a line, x1, y1, and x2, y2, the slope is y2 minus y1, all divided by x2 minus x1. Let's look at a quick example. Suppose we have a line that passes through the points 1, 2, and 4, 8. We can find the slope by plugging these points into our formula. Let's call 1, 2 our first point, and 4, 8 our second point. So m equals 8 minus 2 divided by 4 minus 1. This simplifies to 6 over 3, which is 2. The slope of this line is 2. This means for every 1 unit the line moves to the right, it moves up 2 units. Understanding slope is the key to understanding parallel and perpendicular lines. Now that we've reviewed slope, let's talk about parallel lines. Parallel lines are lines that lie in the same plane and never intersect. Think of the rails on a train track. They run side by side forever. What do you think must be true about the steepness of two lines that never intersect? They must be going in the exact same direction. And that's the key. The rule for parallel lines is that they must have the exact same slope. If two lines have the same slope, they are parallel. Let's see this visually. Imagine a line with a slope of 1/2. It goes up 1 unit. For every 2 units, it goes right. Now, if we draw another line with the exact same slope, 1/2, but starting from a different point, you can see they are perfectly parallel. They will never meet. So to check if two lines are parallel, all you need to do is find their slopes and compare them. If they are equal, the lines are parallel. Let's work through an example. Are the lines y equals 3x plus 2 and y equals 3x minus 5 parallel? To answer this, we need to find the slope of each line. Both equations are in slope-intercept form, y equals mx plus b, where m is the slope. For the first line, y equals 3x plus 2, the slope is 3. For the second line, y equals 3x minus 5, the slope is also 3. Since the slopes are equal, m1 equals m2, the lines are indeed parallel. It's as simple as that. Now, let's try a slightly more challenging example. Are the lines 2x plus 3y equals 6 and 4x plus 6y equals 12 parallel? These equations are in standard form, ax plus by equals c. To find the slope, we need to convert them to slope-intercept form by solving for y. For the first equation, we subtract 2x from both sides to get 3, y equals negative 2x plus 6. Then, we divide by 3 to get y equals negative 2/3 x plus 2. The slope is negative 2/3. For the second equation, we subtract 4x from both sides to get 6y equals negative 4x plus 12. Dividing by 6 gives us y equals negative 4/6x plus 2. This simplifies to y equals negative 2/3 x plus 2. The slope is also negative 2/3. Again, the slopes are equal, so the lines are parallel. In fact, notice that these are the exact same line. They are parallel and coincident. Now let's move on to perpendicular lines. Perpendicular lines are lines that intersect to form a perfect 90-degree angle. Think of the corner of a square or the intersection of a horizontal and vertical line. The relationship between their slopes is a bit more complex than for parallel lines, but it's still very predictable. The rule for perpendicular lines is that their slopes are negative reciprocals of each other. This means if you multiply their slopes together, you will always get -1. Let's break down what negative reciprocal means. The Promosson-Gersel negative part means you change the sign of the slope. The Promosson-reciprocal part means you flip the fraction. So if a slope is a over b, its negative reciprocal is negative b over a. Let's look at some examples. If a line has a slope of 2, which is 2 over 1, its negative reciprocal is negative 1 over 2. So a line with slope 2 is perpendicular to a line with slope -1/2. If a line has a slope of -3/4, its negative reciprocal is positive 4/3. So a line with slope -3/4 is perpendicular to a line with slope 4/3. Let's see this visually. Here's a line with a slope of 2. Now, let's draw a line with a slope of -1/2. Notice how they cross at a perfect right angle. This is the visual representation of perpendicularity. So, to check if two lines are perpendicular, find their slopes and see if they are negative reciprocals. You can also multiply them together. If the product is -1, they are perpendicular. Let's practice with an example. Are the lines y equals 2x plus 3 and y equals -1/2x minus 1 perpendicular? First, we identify the slopes. The slope of the first line is 2. The slope of the second line is -1/2. Now, let's check if they are negative reciprocals. The reciprocal of 2 is 1/2. The negative of that is -1/2. This matches the slope of the second line. So yes, they are perpendicular. Alternatively, we can multiply the slopes together. 2 times -1/2 equals -1. Since the product is -1, the lines are perpendicular. Let's try another one. Are the lines 3x plus 4, y equals 12, and 4x minus 3y equals 9 perpendicular? Again, we need to find the slopes by solving for y. For the first equation, we get y equals -3/4 x plus 3. The slope is -3/4. For the second equation, we get y equals 4/3 x minus 3. The slope is 4/3. Now let's multiply the slopes. -3/4 times 4/3. The 3's cancel, the 4's cancel, and we are left with -1. Since the product is -1, the lines are perpendicular. Now that we can identify parallel and perpendicular lines, let's use this knowledge to write the equations of new lines. Our goal is to write the equation of a line that is parallel or perpendicular to a given line and passes through a specific point. To do this, we'll use the point-slope form of a linear equation. The point-slope form is y minus y1 equals m times the quantity x minus x1. Here, m is the slope of our new line, and x1, y1 is the point it passes through. The strategy is always the same. First, find the slope of the given line. Second, use that slope to find the slope of your new line. Same for parallel, negative reciprocal for perpendicular. Third, plug that new slope and the given point into the point-slope form. Finally, simplify the equation into slope-intercept form, y equals mx plus b. Let's write that down. Step 1. Find the slope of the given line. Step 2. Find the slope of the new line. Step 3. Use point-slope form. Step 4. Simplify to slope-intercept form. Let's start with a parallel line example. Write the equation of a line that is parallel to y equals 2x plus 5 and passes through the point 3, 1. Step 1. Find the slope of the given line. The equation is in slope-intercept form, so the slope is 2. Step 2. Find the slope of our new line. Since our new line is parallel, it must have the same slope, so the slope of our new line is also 2. Step 3. Use point-slope form. We have our new slope, m equals 2, and our point, x1, y1, equals 3, 1. Plugging these in, we get y minus 1 equals 2 times the quantity x minus 3. Step 4. Simplify to slope-intercept form. First, distribute the 2 on the right side to get 2x minus 6. Then, add 1 to both sides to isolate y. This gives us our final equation, y equals 2x minus 5. Notice that our new line, y equals 2x minus 5, has the same slope as the original line, y equals 2x plus 5. This confirms they are parallel. Now for a perpendicular line example. Write the equation of a line that is perpendicular to y equals -1/3 x plus 2 and passes through the point 4, 5. Step 1. Find the slope of the given line. The slope is -1/3. Step 2. Find the slope of our new line. Since our new line is perpendicular, its slope must be the negative reciprocal of -1/3. The reciprocal is -3, and the negative of that is +3. So the slope of our new line is 3. Step 3. Use point-slope form. We have our new slope, m equals 3, and our point, x1, y1 equals 4, 5. Plugging these in, we get y minus 5 equals 3 times the quantity x minus 4. Step 4. Simplify to slope-intercept form. Distribute the 3 to get 3x minus 12. Then, add 5 to both sides to get y equals 3x minus 7. This is the equation of our perpendicular line. Let's check our work. The slope of our new line is 3, and the slope of the original line was negative 1/3. Their product is 3 times negative 1/3, which is negative 1. This confirms they are perpendicular. Let's check our work. The slope of our new line is 3, and the slope of the original line was negative 1/3. Their product is 3 times negative 1/3, which is negative 1. This confirms they are perpendicular. Let's recap what we've learned today. We started by reviewing slope, the measure of a line's steepness. We then learned that parallel lines have the exact same slope, while perpendicular lines have slopes that are negative reciprocals of each other, meaning their product is negative 1. Finally, we saw how to use the point-slope form to write the equation of a new line that is parallel or perpendicular to a given line and passes through a specific point. You are now able to determine if two lines are parallel or perpendicular by comparing their slopes, and you can write the equation of a line that is parallel or perpendicular to a given line. Great job!